Our beloved principal, Professor R. Raghavendra sir, we welcome you, sir. Our advisor, madam, Dr. R. Shanti Iyer, madam, we welcome you, ma'am. IQSC coordinator and head of Department of Commerce and Management, Professor Bhavya K.R. ma'am, we welcome you, ma'am. Department of Language head, Dr. Janardhan sir, we welcome you, sir. Department of Arts head, Dr. Rikia Ghoshal ma'am, we welcome you, ma'am. And all my dear colleagues and our lovely participants. I, Professor Mohanisti, Assistant Professor of Computer Applications, Dr. NSAM First Grade College, Krishnarajapura Village, Bengaluru. Welcome you all for IQSC initiative 5 days national level faculty development program on research applications in artificial intelligence and machine learning, which is organized by Department of Computer Applications. The objective of this FDP is to unlock the concepts of artificial intelligence and machine learning in research perspective in the field of machine games, speech recognition, language detection, computer vision, expert system, robotics, and other fields have potential. To create technology that allows computers and machines to work intelligently. Now, I would like to introduce the resource person to the participants. I welcome and I ask our HOD sir to introduce the resource person for today. Over to you, sir.
Good afternoon all. I think it's audible. She completed her MPhil in computer science from Tiruvallur University and MCA from University of Madras. She holds 14 years of teaching experience. Her research areas include machine learning and data analytics. She has published 1 Scoopus indexed, 1 patent, and 2 UGC listed journals. So revived a book of Java programming for NEP syllabus. She has also presented more than 5 papers at national and international level seminars as well as conferences. So once again, we welcome you, ma'am, for this faculty development program. And I thank you for giving this opportunity. Now I'll hand over to Mohan, sir.
Thank you, sir. We welcome you also, sir. Now, without further, I will hand over the session to Professor S. Maheshwari, ma'am, our presenter for the today's session. Over to you, ma'am.
Good afternoon, one and all present here. First of all, I would like to thank our Raghavendra sir for giving me this opportunity to present this. And I thank Dr. Naveen and Mohan sir for this opportunity. So is my screen visible?
Yes, ma'am. Yes, ma'am.
Shall I start, sir?
Yes, yes, ma'am.
So good afternoon, all my dear teaching fraternity. Thanks for the opportunity given to me for presenting this presentation for you all. So today my topic is on machine learning and its applications in the AI and how we are going to implement using Python. So before going to the implementation, I'll just discuss about the machine learning and what is machine learning and what are the algorithms are available in machine learning. After that, we'll just move on to the implementation. So we all in this new era, that means in past 2 years, most of us will be hearing about machine learning. What is machine learning? It's nothing but a subset of artificial intelligence. And so if you see that by general, if you want to tell, the machine learning is nothing but making a system to work as like a human. So it will be learning it's by itself, or it will be told to learn from other data what we are giving. Based on that, it will be showing the data. So in that case, everywhere we are using this machine learning, even in our home and even in the shopping malls and entertainment media and healthcare sectors, everywhere we are using machine learning. So now how the machine learning is going to work, and what are the different types of machine learnings we have. So machine learning will be allowing us to process the data and learn, and from the data we'll be learning it and we'll be getting more smarter. So how the human will be reacting to the situation, and how the human are learning from the each and everyday life situations. They'll be learning each and every day. There is a lesson to us to learn, right? The same way the machines are going to learn from the data what we are going to give. So accordingly, the machine learnings can be the real-time examples. When we see the everyday life, we are just going through all the different machine learning data. If we see that we are using the Google Maps, right? It's giving us the direction. This is also a part of our AI. That is also a part of our machine learning. And search engines we have, and which is used for searching the data in the Google or whatever we have, that is also a part of our machine learning. And we'll be able to detect the online frauds. All these things will be based on the machine learning only. Even the medical diagnostics, virtual personal assistant, and image recognition, like we have our biometric system in the colleges, where it will be detecting our face, the attendance to us. All these will be coming under the machine learning only. And email spam filtering is also a part of the machine learning, where it will be just bifurcating which is the spam mail and which is not the spam mail. That is, the correct mail will be coming to our inbox. If it is a spam mail, it will be sent to the spam box. All these based on the machine learning only. So when we consider the machine learning can be classified into three, basically supervised learning, unsupervised learning, and reinforcement learning. What is mean by supervised learning? When we are giving the when we are working under the supervision of a person, we'll be told to do this, that, and all. So based on that supervision of that person, we'll be doing the work accordingly. So that is called supervision learning. So when a child is born, the child will be taught by the mother, telling that this is apple, this is carrot, and this is thing, this is this thing, this is that thing. So based on the continuous teaching of the mother, one or the other day, after 2 or 3 years, the child will be able to analyze that. When it sees an apple, it will tell apple. When it sees a pen, it will tell pen. So that is called supervised learning. So when we take it as a child as a program, the program will be taught that this is this, this is this. It will be keep on telling the things under the supervision of one person. It will be trained like that, and based on that, the output will be generated. That is called supervised learning. Under supervised learning, we have two different types: classification and regression. And unsupervised learning, if you take, so under the supervised learning, we have different techniques where the supervised learning is implemented in real time. So if you see that we are implementing the supervised learning in the spam filter detection. That is what I showed in the previous slide. The spam filter will be able to do by using the supervised learning only, because the algorithm has been trained in such a way that whenever it finds the spam mail, it will be sending it to the spam folder. So that spam filter is one of the supervised learning algorithm which has been implemented in our mails. And the image recognition, it's also part of your supervised learning, because the kids will be trained, right? This is your auntie, this is your uncle, like that. When they teach one or two times, when they teach, the third time that child will call that we'll be having the credit scoring systems also. The credit scoring systems also based on the supervised learning, whether this person is having a credit score or he's not having, based on his previous data, how he has paid the loan amounts, and how you are having the data, how he can pay the data, how he can pay the money, whether he's paying the money or not properly. Based on the data, they'll be recognizing that the credit score of a person also. And as well as in medical diagnostics also, we can use this supervised learning, where it will be detecting whether cancer is there or not, whether diabetes is there or not, whether heart attack will occur or not. So this will be, basically the supervised learning will be based on the concept called probability, 0 and 1s. The supervised learning is based on the probability 0 and 1, when it will be lying between 0 and 1 only. So usually we'll be using the classification data here and regression data by doing this supervised learning. And in unsupervised learning, it is like a person who's learning by themselves. That is called unsupervised learning. A best example, Ekaleva, we can tell, he learned himself. He learned himself. So that way, an algorithm will be given in such a way that it will be learning by its own, so that it will be getting the good ones and the bad ones, and it will be able to bifurcate the data in that. So one of the main thing what we'll be using in unsupervised learning is clustering and association. So clustering will be segregating the data. That means the grouping of data will be happening in the clustering. What is meant by clustering of data is, see, when you buy a bulk of vegetables from a shop, what the shop person will do, he'll be putting everything in your bag. So when you come home, what you'll do will be segregating the vegetables up to the its name, right? So the same way, when you have a bulk of data given to the machine, what it does is it will be segregating the data based on its features. And if we are giving the data of animals, it will be segregating the animals based on its features. Like these are all cows. These are all, because the cow can be, it is not that all the cows will be in the same way. If one cow will be in black color and the other cow will be in black and white color, the other cow will be in a brown color, like that it will be. So, but everything comes under cow only. That clustering will be done by the unsupervised learning. By seeing the features of that particular animal, it will be segregating it. The same way we have an association also. Yes. Mohan sir. Mohan sir.
Yes, ma'am.
Sir, am I audible?
Yes, ma'am. Yes, ma'am.
Sir, but someone asked something. Any doubts?
No, ma'am. No.
Okay, sir. So the other one is reinforcement learning. The third one is reinforcement learning. In unsupervised learning, the best example for unsupervised learning is we all will be using our Amazon and Flipkart websites, right, for buying our products. So under that, when you are buying the product, it will be showing us these are the recommended items for you at the base when you are going for surfing for your data, right? So when you are surfing for the data, it will be showing us at the bottom, these are the recommended items for you. How it is giving means it is based on your unsupervised learning. So it will be based on the items which you have purchased. It will be analyzing it and it will be showing that these are the items which you can like. So this is based on the unsupervised learning. So the third one is reinforcement learning. Reinforcement learning, it's like a best example is, again, I'll take a kid, okay, or a student. You can consider the student also. So when a student does a mistake, either we'll punish him or we'll be telling him to not to do, right? One thing is punishing is the one thing. Through his punishment, he'll realize that he should not do it. When we praise a student, he'll be realizing that he should perform better, right? So these are the two things what we can do. One is the negative reinforcement. The other one is the positive reinforcement. So negative reinforcement will be telling that there is a negative feedback. That means you should not do this. Otherwise, you will be punished. That is what we'll be telling to the student. So based on that punishment, he'll be realizing his mistake and he'll be giving the proper result. So that is what is called negative reinforcement learning. So the algorithm will be given a feedback form. Here in reinforcement learning, we'll be having a feedback system where you'll be analyzing and the feedback will be fed back. How we do in the neural networks, the feedback will be again fed into the processing system, so that when you have the input A and B, along with the A and B input, there will be a feedback F also. So based on the feedback, the output will be coming. So each and every time when you are processing the data, better results you will get. Then positive feedbacking means you have done better. You can do better in the next examination. When we give pat a student, the student will be telling that I can do more. So that is called positive reinforcement learning. So positive reinforcement learning will be helping the algorithm to fine tune itself so that it will give a better results. I can give an example. Nowadays, we are all using ChatGPT. I hope so. So the ChatGPT is an artificial intelligence based application where we'll be searching for our contents, or whatever question we'll ask, it will be answer for us. Whichever it is, it will be answering for us. So when we are questioning the ChatGPT, it will be giving us a result. Based on the result, if you ask once again the same question, it will understand or analyze that the answer what it has given is wrong, and based on that answer, it will be showing us a new answer to that, because it is learning from that question that it has done some mistakes to the previous answer, and it will be giving us a new answer. So this is a type of reinforcement learning what we are seeing in the real-time world nowadays. Not only that, we have the finance system and the online advertisement. All these will be coming under reinforcement learning. So we'll see how the supervised learning work. So when we come to the supervised learning, we'll be giving an input. It is raw data. It is a data which will be feeding to the system. When we feed it to the system, the entire data will be divided into two. One is the training set. The other one is the desired output, or you can tell it as a test data. So we'll be dividing into training data, and the test data will be, training data will be tested based on the testing data. This is the desired output what we'll get. So algorithm will be applied for it, and it will be processed, and it will be giving the output for you. So based on the training set, because we'll be training the system in such a way that if it is red color and round in shape, it is all apples. If it is yellow color, oval in shape, it is all mangoes. If it is this is balloon shape and it is having a lemon yellow color, it is called pears. Like that, we'll be training the data set so that it will be giving the output properly, that this is apple, this is mango, and this is a pears. Like that, it will be segregating. So the data will be divided into two sections here, training set and the test set. So based on that testing set, the training data will be applied on the test set, and it will be producing the output based on the algorithms what we are supplying. Under supervised learning, some algorithms are there. I'll go back to that in the next slides. And unsupervised learning, how it works is, there will be already some data will be given as an input. So there won't be any training given to that form, but there will be an interpretation that if this, it has to be taken as a process like this. So it is not that we are training the algorithm. We are not training the data set. We are just giving the interpretation that if it's red color and round in shape, it should be apple. And if it is yellow color and lengthier shape, it will be banana, and round in, I mean, oval in shape and in yellow color, it will be mango. Like that, already some interpretation will be given to the algorithm. So there won't be any unknown output. There won't be any trained data set here. Training data set won't be there. We'll be having only the test data. Based on that, algorithm will be applied, and process will be giving us a proper output. Sometimes there are chances are there that in unsupervised learning there may be some mistakes, because apple is also in red color and tomato is also in red color. If the dimension and the color is similar, if the dimension of the apple and the dimension of the tomato is similar and the color is also similar, sometimes apple may go to tomato or tomato may come to the apple also. That happens in the supervised learning. That is one drawback of the supervised learning. And reinforcement learning, as I told you already, the raw data will be given, and there will be an agent which will be selecting the algorithm, and environment will be there. It will be giving a reward. That is a feedback system will be there. Okay, when we have an algorithm, a feedback system will be given. So when it is processing the data, based on this, if for example, in the previous example, when a tomato is sent to the apple state, it is not an apple, it is a tomato, right? We have to segregate it on the apple. So, but what happens is this based on the reward, whether it is a correct or not, we don't know. It may give a positive result or it may give a negative result. Based on it, when you give a feedback, again, it will process it by based on the another features which we have mentioned for tomato. It may segregate the tomato to tomato, not to the apple. That will happen in the reinforcement learning. That is what will be applied in the reinforcement learning. This is how all the three algorithms are working in the machine learning. And when we are seeing the overall system of the machine learning, input data will be given, we'll be developing a model, we'll be training a model, and the test will be done and analysis will be done and retraining will be done, and you will be getting the output. This is how the entire process of machine learning will be working on. And if you come across the machine learning algorithms, what we have under supervised learning, we have regression algorithm, decision tree, random forest, and classification algorithms are there. Under regression algorithms, linear and polynomial regressions are, and under classification, KNN, TRES, and logistic regression, Navy Bayes, support vector machine. All these are the algorithms which will be coming under classification. Under clustering, we'll be having support vector and PCA and K-means algorithm, association learning, a priority algorithm, and FP growth algorithm. Hidden model will be there. So here, this clustering will be based on continuous data, and the associative learning and the classification will be based on the categorical data. So all this regression, random forest, all under the continuous data, and classification, association, and intent Markov will be working under the categorical data. So when we come under the supervised learning, here I have given the same thing which we have saw in the previous slide, and it is a cheat sheet which will be reflecting that what is supervised learning, unsupervised learning, semi-supervised learning, and all. So when you see that what is semi-supervised learning, it is a combination of supervised and unsupervised learning. So sometimes we have to train the people, sometimes we no need to train the people. Once we have trained the people, we no need to keep on training the people in our associations or in our workplaces. So that will be coming under the supervised learning. So what are the libraries we are using? What are the libraries we are using here for this machine learning frameworks? And the libraries what we'll be using is, the main frameworks what we are using are Matplotlib, Natural Language Processing Toolkit, that is NLTK, Pandas, Scikit-learn, and Seaborn, NumPy, Keras, SciPy, PyTorch, and TensorFlow. These are the packages. In Java, we'll be calling it as a package, and in other programming languages, we'll be calling it as an header files, right? The same way, all these are the packages which will be used in the Python. So for visualizing the data of your machine learning. So we are presenting the data. If it is in a numerical way, it won't be understandable by the normal people. But when you are presenting in the visualized form, the data will be more attractive and understand by the people. So that's the reason more visualization is done by using the machine learning algorithms. So basically the used one are Matplotlib, Pandas, and Seaborn. These are the three things which we'll be in need of plotting the data and the visualization. And Scikit-learn is the main package which is used for your machine learning algorithms. So Scikit-learn is the main package for your machine learning algorithms. So we'll be seeing how we can plot with data with the Pandas. So the Pandas are the one of the library where you'll be having more methods in it, more functions are there. The functions are used for representing the data. So which will be used for presenting the data. So here we have a method called .plot. We can call it as a method or we can call it as a function, which will be used for plotting the graphs. So here we have given x-axis, y-axis, and kind. This is the main thing. Sorry. This is the kind is the main one which is used for plotting your maps. So we have 11 different types of maps which can be mapped by using this plot method in the data frame sets in the Pandas. We have line, we have pie graph, we have bar graph, we have scatter graph, everything we have. So with the help of this pandas, we'll be able to do this. By this, I'm ending up my theory session and I'm moving back to the presentation of my program. I'm launching my new Jupyter notebook where I'll be showing you some of the pandas methods and as well as the machine learning algorithms, how we can implement now. The first, what we are going to see is how we can retrieve the data sets. I'm going to use a heart attack data set, which is available in kaggle.com, or there are so many repositories out there where you can take your data sets. The data sets are useful for our basic level researchers. So the basic level researchers, those who want to perform the basic level research or the beginner of the research can take this data sets from the websites. So you have UCI repository. That is one of the best repository where you will be finding all the data sets. And as well as we have kaggle.com, which is another repository where you will be finding the data sets. So if you see that when you want to read the data set to your Python programming, we need to import pandas. Okay, panda is the one which working with our numerical data and as well as the data what we are going to handle in our machine learning. So the pandas, these are the libraries which we have to import whenever we want to work with our panda programs. So you can see here from pandas import read CSV. So pandas is a library where you are importing a class called read CSV. Read CSV is it's a method which is going to be used for reading the CSV files from the your system. That is your comma separated values. Comma separated values, it's nothing but our Excel sheet only. Nowadays, the data which we have is enormous. The data cannot be stored in our databases nowadays. So we are going with the Excel sheets. So read CSV is a method which is used for reading your data sets from your system or from the online sources, whatever you have. And pandas, we have plotting, which is used for plotting the graph, where we'll be using the scatter matrix, which will give the scatter matrix. And matplotlib is also one of the library where you will be having a pie plot, which is used for plotting the graphs. And scikit-learn, sklearn, and sklearn model selection will be there. This is used for splitting your data, because when we go for the supervised learning, the data has to be splitted into, we don't know how to train the system, right? So what we have to do is we have to split the data into two. One is the train set, the other one is the training set. Two divisions has to be done in the existing data itself. That means how we'll be dividing the students. These are all good students who will study well, and these are the students, poor students. Based on the good students, we'll be training the weak students, right? The same way here also, the data set will be having a set of data where it will be divided into two. One will be used for training the other data to get the results from it. So that is how it will be used. So sklearn is a scikit-learn. This is a library what will be importing for our dividing the set, and will be it will be helpful for us to do the scoring also. So metrics will be having classification report, confusion matrix, and accuracy score, and all. If you want to take, all these will be downloaded from the sklearn metrics. That means sklearn is a scikit-learn library. So when you want to visualize the data, we have to first read the data which is available in our system, right? So what we'll be doing is Panda will be using, see, I already have done the program and diacate because of time constraints. I have made it short. From Pandas, import CSV. From Panda plotting, we'll be doing the scatterplot and matplotlib pyplot. We are going to load the data set. How we'll be loading the data set is, we'll be fixing the URL, that is your path of your file. I have stored my file in D drive and the folder called heart, and heart.csv is the CSV file which I'm storing to the URL, and read CSV is the method which is used for when you pass the URL as a parameter. Read CSV file will be reading the data from that database. That means from your folder, and it will be assigned to a variable called dataset. It will be assigned to a variable called dataset. When you are printing it, you can see the data is printed on the screen. This is a heart attack data which is having 14 columns of data, where it is mentioned as age, sex, and we have the other data which will be giving us the cholesterol level, and before fasting, what is the heartbeat rate, and after fasting, what is his heartbeat rate, when he's taking rest, what is the heartbeat rate, and the slope rate, and always all these data will be supported here. This is a 14 column data. You can see here from age to output, 14 column data has been displayed. And when you are displaying the print.data shape, this will be giving us what is the matrix of that data set. That means it will be showing us how many rows and how many columns are there. 339 rows and 14 columns data. This is the shape of the data set. So if you want to include more data to this, you can include, or if you want to see always what we'll do is we'll be doing the pre-processing of the data before we apply this data to the machine learning algorithms. What is mean by pre-processing is removing the empty null data as well as unwanted data from this. But that part I didn't touch here. But the thing is, you can apply some methods here. That means in built-in functions are there, which is used for pre-processing of the data. That will be removing the null data as well as repeated. That means redundancy of the data and all will be deleted from it. So if you see here, we have the proper data, which is of 339 rows, and the 14 columns data is there. So I was able to show the data set here and the shape of the data set by using these two methods called print of data and print of dataset dot shape. So print of dataset will be printing the entire database, and as well as shape will be giving us the shape of the data set, how many rows and how many columns are there. And here we have a plot. We are going to plot it by using the pandas, which I showed in the PPT. Dataset.plot, kind is box plot, and subplots through layer 4. These are the other parameters what we have in the data set. We have the data set, plot. The kind is the box plot, right? It will be giving us the box plot data here. So the box plot is used for giving the mean value and skews and the median value of the data, and it will be giving first quartile means what is the data, and second quartile what is that data represents, and we have the third quartile and fourth quartile here. Based on that, it will be box plot will be plotted. Not only the box plot, we can see the data set by other methods also. Here is a other method which we have implemented, dataset.hist. Hist means it is a histogram. We are going to apply histogram to all the columns. It's going to apply for all the columns. You can restrict it by giving only one particular column also, or two columns also you can restrict. But here I have applied for all the data set. Pyplot.show, when you give, the pyplot is available in the matplotlib, which is going to show the histogram of all the columns. So you can see here age histogram, this is sex, and the CP, TR, TBS, and cholesterol, and FBS before fasting, and rest ECG, what is the rest ECG of that person, and all these things will be shown in the histogram format. So you can see that the scatter matrix also will be available here. This is the scatter matrix. you can show here, this is the histogram it is showing in the top. This is the histogram, and scatter matrix of the data set will be giving us the scatter matrix of the data set here. Everything scattered and plotted against one other. So this is the age. Based on the age, what is its other criteria belongs to? Based on the sex, what are the other criteria? Based on one parameter, the other parameter will be discussed in this scatter plot. And when you are describing the database, you have to give dataset.describe. This is used for knowing all the statistical value of your data set. So giving us the count of the column and the mean value of the columns and standard deviation, the minimum value and the maximum value, first 25% of the data, 50% of the data, and 75% of the data will be shown to us as a statistical value. So when you want to know the statistical value of a data set, that time you'll be using the method called describe. You'll be using the method called describe. So this describes the entire data set for each and every column in the data set. And here again, scatter matrix comes. And this is the group by data. This is a method which is used for group by, dataset.group by age. So you'll be age wise, you'll be grouping the data set. In SQL, we'll be applying a grouping function, right? Group by function we'll be using in the SQL. So select star from employee, group by the employee salary greater than, like this we'll be giving, right? The same way here, we are using the group by age, and size we are giving dot size. When we are giving the age is 29, means five members are there in the age of 29. So 34 age means 5 people are there, and 35 means like that. It will be grouping the number of people who's having that particular, this is giving the size of that age, because if you see that, it will be giving the data type of that age also, and it will be giving us its group by the size of the, group by the age. This age people or 5 people data is recorded here, like that it will be showing. And when you want to see the plot as a bar graph, you can plot the entire data set, or you can go for only 1 or 2 basics. Here I plotted the entire data set. You can see here it's showing very small. Why? Because you can increase the size of the data set also, the graph also, but I didn't do that. It is showing all the data of one particular person or one particular column will be shown together in one particular bar graph. So this will be as a bar graph what you can show. When you give the head command, this head command will be displaying as the top 5 rows in our data set. Top 5 rows in the data set. It is like a select star from employee whose salary is greater than 1,000, and count wise, if you want to store, if you want to display, it will be displaying only the top 5 employees, right? The same way, your head is the only method which you will be giving to show the top 5, first 5 data set values. If you want to increase in the parameter column, if you give 10, it will be showing the 10 rows of your database. So this is how we'll be plotting with the pandas. And we'll coming back to the train set, and we'll be splitting out the data set, right? How we can split the data set is array equal to dataset.values. We are taking the entire data set, and the values will be made as an array. In that array, we are splitting the X array and Y array. So the X array will be taken from 0 to 4. This is like it is a list here. We'll be calling it as a list in Python. So it will be starting with the data, and we'll be taking the percentage of data will be taken as X array, and the 4th column will be taken as Y array. So we'll be training that train split X comma Y train. X comma Y is the array what we have taken, and then train size is 20% of the data will be taken for training. So the remaining random state 42 is the it's a default one what we'll be giving in this. So X train comma X validation, Y train comma Y validation equal to trains test split. This is a built-in method which is going to split your data into 2. One is the train set, and the other one is the training set. So where it will be available is, it will be available in scikit-learn model selection. This is a library where you will be finding the train set split method. So where you will be importing it. Without importing that, you cannot divide the data into 2. Okay, this is how we'll be dividing the data. Now, after dividing the data, how we are going to implement the Python programming. I'll just one second. I'll just open that file. Okay. Opened now the heart attack analysis data set, and I'm going to implement a different machine learning algorithms in this. If you see that these are the files which you have to import before doing the program. So what, one second, up to here we have to, this is import numpy as NP. That means you are assigning a variable for the numpy as NP, pandas as PD, matplotlib pyplot as PLT, and collections import counter. We are going to import the counter, and matplotlib.pyplot as PLT. These are, you can consider this as all as NP is an object of NP numpy, and PD is an object of pandas, and PLT is an object of matplotlib and pyplot, and PLT is an object of matplot pyplot. And we are going to cborn as SNS. We are going to, so these are the packages what we have to import in our program. So in this also pyplot.express and pyplot.figure-factory and scikit-learn pre-processing, label encoder, label model selection, train test split. So this is used for splitting our data into two, train test, and the training data and the testing data will be splitting here. And py waffle, we need this waffle for waffle matrix. That is, as of now, we have seen different types of maps, right? This is also one of a map, waffle map, we'll call it as, and we'll be importing the matrices, scikit-learn matrices. And in the scikit-learn only, we have the packages which is used for our machine learning algorithms. You scikit-learn that .navy bias will be importing Gaussian NB algorithm, and assemble will be importing our random forest classifier, and assemble will be importing gradient boosting classifier, and metrics classification report, and accuracy score and confusion matrix. All these will be belonging to the scikit-learn package. So sklearn, that is, we will be calling it as sklearn. sklearn is a best package for our machine learning algorithms. So in this, if you are implementing this, you no need to bother much about your basic algorithms. Usually what we'll do is we'll be writing the algorithm and we'll be training the data, and we'll be implementing all the algorithms, like how we'll write a logic for our program. We'll be writing the logic, and based on that logic, we'll be training, and we'll be checking whether that algorithm is working properly or not. But here already we have all these as an built-in packages, and built algorithms are there. Based on this, we are going to visualize the data, and how we are to analyze the data, we are going to see it. That's the reason nowadays they are using Python or language for the machine learning. So these are the two important languages what we'll be using for it. So we have installed all the packages, and then I have read the data set in Panda. PD is Panda. That is pd.read CSV file. That means in the previous example, I told that dataset equal to read CSV, dataset of read CSV URL we have given. But here we are using the Panda object, and pd.read CSV. It will be reading the dataset, and it will be assigning to the df. That is a variable where you will be having the dataset as a pointer. So if you see that, we can draw the pie graph. We can mention the histogram for age and only for the data columns. So df.columns, we are taking only the age as one factor, and based on the age, we'll be showing the histogram, whether here you are passing the data set as a input, and x is the age of the person, that is the x-axis. And you can see here the color is equal to the output. Marginal is box 1. And if you see that have H over data if columns, all the columns color discrete will be setting the figure dot show when you give, it will be showing the age matrix, based on the age, what is the count of that particular age? That means in 29 age, you can see your age between 25 to 29, count is 2. And age between 30 to 34 is count is 3. And age between 35 to 39 is count is 11. Like that, it will be showing us the count over here when you pass over this. So this is why we will be writing this. This is a general histogram, what we are plotting against the age and the count of the age. And now the main thing which we are coming here is y equal to df of output. That is the last column of your data set. The last column of your data set is output. That will be assigning it to a y variable. We'll be assigning it to the y variable because the output is the one which will be telling whether that person will get heart attack or not. Okay, whether the person will get heart attack or not. If it is 1, he won't get the heart attack. If it is 0, he'll be getting the heart attack. So in that case, we are going to use that as a y-axis, and data will be the remaining 13 fields. So from the age, sex, and the cholesterol level, all these levels will be considered as one set. The y will be considered as the another set. So what we are going to do is, for the y, from the data set, the output column will be assigned to y, and data equal to df dot drop of output axis 1 means that one particular column we are going to drop it from the data set. Data dot head when we give, data will be dropped, right? So data will be dropping, so we won't get any data set. And x train, x test, y train, and y test, we are going to split the data accordingly. So what we are going to do here is, will be giving x and y values, right? X value is your remaining 13 fields of your data, and y value is the last field output of this. The test size will be considered as 0.20. That is the 20% of the data what you have taken. For example, now I have taken 333 rows, means out of the 333 rows, 20% data will be selected for the training. That is used for training. So that means 65 records will be taken for training. And random state is either we can give it as 42 or 0. This is not going to affect our data set. So this is how the train set and the this is available in our sklearn package. So after that, I'm going to apply one algorithm. I have applied 4 or 5 algorithms here. First, I'll explain one algorithm. So from yellow brick classifier, import classification report. Okay. So yellow brick classifier is a package where we'll be using the classification report, because here we are going to use decision tree classifier algorithm. So the model is a variable where you'll be giving tree.decision tree classifier, because tree is a package where you have the decision tree classifier. So you know that tree means you will be having the root and the child in it. So the maximum depth of the root will be 15. So up to 15 level, it can go and it can trace the data, and it will be giving us the data. And CLF is equal to model.fit x train comma y train. That means we are going to give the this fit is going to select the training data, that is your x data, and the y data will be fixed over there. And y predict equal to CLF dot predict of x train. That means predict the output based on the trained data x train. You are going to give the trained data, because we have already told that if this is the age and this is the cholesterol level, this person may get an heart attack. This is the trained data. So that case, what happens is y predict will be our output, where it will be predicting based on the x trained data. So x train will be the data which you already got from the trained trained data. That is 20% of our trained data. Train accuracy will be calculated here, how much it is going to give the Y predict and Y train it has been taken. So already we trained the output also. This means this is the output and this means this is the output. We have already trained the output also. Based on the output, it will be predicting whether that it will be giving the accuracy score, whether we have predicted it properly or not. The same way, Y valid CF predict X test also will be based on the test data, trained data, and even the test data will be predicting, and will be calculating that text accuracy here by using the accuracy score of Y valid and the Y test, whether it is a valid data or Y test data. Then after that, we'll be plotting it in the map, so that we'll be see it the whether the data which you have got is correct or not. This is called as an heat map. We'll be plotting it as waffle map. What is meant by waffle map means which is shown in that form of tiles is called as. This will be showing the data in the form of waffle map, and this is called as an heat map. Heat map will be shown in the rows and columns, which will be different colors will be applied. So to plot that, we have some methods here. We have this figure. So figure equal to PLT dot figure size 12,5. And this is the plot is from matplotlib, and figure will be taken as figure size of 12,5. And figure equal to plot dot subplot of 1 to 1 means it is just first row will be having 2 columns, and this is the first element. That means we have plotted 2 maps in the same row, right? If you are not giving this, 2 maps won't come in the same row, it will go down. So for that, we have given here plot lot subplot 1 to 2, 1 to 1 and 1 to 2 is the thing which we have to use when we are using it to print in the same row. So this represents that first row, 2 columns, and again first row, second column, 2, that is like second position. So this will be confusion matrix will be printed here. The confusion matrix will be telling us about how our data has been trained and based on the Y test and Y validity. So output is tested and output is valid. So based on that, whether, see here, the confusion matrix, how we'll be plotting this, we have the map of our logic gates, right? True, true means true, true, false means false, false, true means false, then false, false means false. Like that, we'll be getting the truth table of a logic gate, right? The same way this confusion matrix also will give. So, but it's not, it's like true, true means positively negative, like negative, negatively false, positively true, positively, negatively true, negatively false, like that it will be coming. So based on that, the data will be printed. So how many people will be getting, see, you can see here 0, 1, 0, 0, and 0, 1 and 1, 1 will be given. So you can see that how many people will be coming under that, that will be given as the scales. So this both will be in one scale of this scale. 29 and 27 is again will be another scale. This is like our confusion matrix, whether they'll get heart attack or not will be decided based on this image. And then we'll be plotting the heart attack, whether they'll get heart attack or whether they won't get heart attack based on the model what you are supplying. In the classification report, we'll be giving the model because it's a decision tree classifier model. That model will be sent as an input here. And when you see that visualization fit will be, you will be using the trained data for fitting the data, and score will be your test data. So fit will be the visualizer and the model, and test will be the evaluation model of the test data. So we'll be showing that visualization as shown. So you can see here, no heart attack and heart attack will be the 2 waffles what you will get. And based on the precisions, whether they'll get or not, precisions can be seen as a measure of a classifier exactness, how it will be exactly, it will be measuring whether it is correct or not, whether the ratios what it is creating is correct or not. And you will be having a recall classification. This is a measure of the classifier completeness, whether it is able to classify correctly, find all the positive instances, or it is going to give only the negative values. That is called recall. And F1 is a score in weighted harmonic mean. finding out the mean, median, mode, right? So based on the mean, you'll be able to find it. And support is a number of actual accuracy. So here you will be finding out the accuracy of the data, and all these based on this, it will be printing our waffle map here. Waffle map will be pointed. So training accuracy will be 1, and the test 0.82 for this decision tree algorithm. The same way we can apply for the other algorithms also. The only thing what we are going to change here is only for the model, the algorithm will be applied. The remaining code will remain the same. So if you know this well, you can implement it by your own algorithms, and you can see that model is Gaussian NB, that is in Gaussian Navy Bayes algorithm. And you are going to train the data as fit data, and then you're going to predict it. And based on the prediction, if you see that, you'll be plotting again that same data. So the code will be the same. Only the algorithms will be different, because in Python, we have already predefined algorithms for each and every machine learning algorithm, so that you can apply that as it is. Or if you want to try it in your own way, you can write the algorithms and you can try in your way also, so that you'll be getting the other outputs, which is you can just analyze it. That can also be taken as a research when we are using the built-in algorithm, and when we are creating our own algorithms by using this Python. What is the difference between this can also be one of a research part. You can also do that. So here, if you see that the confusion matrix is already given, the training accuracy is 0.8 here, and accuracy is 0.88. And the same way, XGB classifier we are applying, and same way you will be getting as accuracy as 1 and test accuracy as 0.88. And here logistic regression we have applied, that we have to import it from scikit-learn linear model, import logistic regression we have to import. So to the variable model, you are just applying that method. Okay, logistic regression is a method which will be applied for a variable. So this variable will be working as an, it's a algorithm which will be taking care of it. So based on that, you'll be doing this. And random forest classifier you can do. And at the end, you can just compare that algorithms. You can see here, model comparison has been done. Logistic regression, random forest, Navy Bayes and decision tree and XGBoost. What is the F1 score? What is the accuracy of this algorithm? And what is the recall data and precision? And you'll be seeing this precision and the ROC accuracy score. All these, based on this, we can judge that which algorithm is giving the best accuracy. So logistic algorithm is giving the accuracy better than the other algorithms when we apply in the machine learning algorithms. So we can do the comparative study of the algorithms by using these algorithms. So some of the programs I have done here for this mapping only, for this model comparison only. So everything is, so I hope that you understood something from this. And the best websites what you can refer for this, all these algorithms is, you can go for Kaggle and UCI repository. These are the two websites which will be helping us to download our data sets. It's a free of cost. You can download the data sets, and we can do our own programming also. As well as you have some of the websites which is very good for the original websites are there for Seaborn and for scikit-learn. All the original websites of Python is very good. And these websites, if you go, you can learn the, all the plottings, algorithms, all the methods which is used. Visualization is available. And if you don't want to do visualization, you want to analyze anything else, those types of data is also available in those websites. So with this, I'll be finishing my lecture. So the session is open for the questions.
Yes, ma'am. Thank you, ma'am. And I request the participants, if any questions, kindly post it in a chat box. Otherwise, the participants can ask the questions.
आप कर लीजिए। अब कहाँ आप ये जो है ना, एक 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 जमाना था जब जो है ना अच्छा लिखा करती थी, अब नहीं लिखती।
Ma'am, is it audible, ma'am?
Yes, sir, it is audible.
Ma'am, we have one question in chat box.
Yes, sir, I saw the question. Can I know
yes,
the
ma'am.
programming platform for machine learning?
Yes, ma'am.
Right. So either you can go with Python or R language you can use. Python you can use, or you can go with R language.
Ma'am, one more question we are having.
Yes, sir.
What are the real world examples of machine learning?
So, a best example, see, one more question is there. Vijay, how ChatGPT would help in writing codes or learning the codes? So, of course, it is a part of AI. This is a real-time, ChatGPT is a real-time example nowadays what we are using. The ChatGPT is a artificial intelligence based app only. So, when we are asking question, it is getting an answer from our question. It is like a human. Robotics also is one of the machine learning, sir. We are creating robots, right?
Yes, ma'am. Thank you, ma'am.
Yeah, thank you. Because that is what, when I started with reinforcement learning, I mentioned ChatGPT, because in ChatGPT, when you give a question, that is giving one answer at the time. If you retype that question once again, the ChatGPT understands that the answer what it has given is wrong, and it will be realizing that it has to give some other answer for it. So you'll be getting a different answer for it. You just try in ChatGPT. That reinforcement learning, because by its mistake, it will be learning it.
Ma'am, one more question.
Yes,
how
sir.
can supervised learning help in medical?
Yes, sir. In medical field, usually what we'll do, we'll be diagnosing with one particular disease, right? We have to find out whether that person is infected or not, right? Either yes or no. So that case, we'll be using supervised learning. It is a classification of data, whether yes or no based questions will be based on the supervised learning. That is what I told you. We'll be using probability there, zeros and ones. The answer will be lying between 0 and 1. If they are 0, they are not affected with the diseases. If it is 1, they are affected with the diseases. So based on the record of the patients, based on the records of the patients, for example, I have taken heart attack disease here. It is not that we have to see the heart attack. The remaining data also can be taken. If you want to detect a liver patient, so you have to have the chart of that. You have to have the database of that. So the data will be having, the data set will be having how a person is affected with liver, or it will be based on the, yes, sometimes there will be a false detection. Vijay is asking a question, does any possibility of false detection? Yes, it is possible, because it's not a human, right? Even the doctors are doing mistakes nowadays by seeing the all the diagnostic results. When they see also, sometimes they go for a wrong diagnosis. As a human, when they are doing, machine will do, right? We cannot give 100% accuracy, but sometimes it happens that there will be a false detection also. But we are training the system, right? Hope that I have given the answer for you.
Yes, ma'am. Yes, ma'am. I request the participants, if any participant is having questions, can ask in the chat box. Any questions? Just for a few minutes, ma'am. We are waiting for our principal, sir.
Yes, sir.
Yes,
So Ravi Kumar is asking how AI is used in stock market operations to predict the stock market, sir, whether it will be going up or down based on data or based on the previous results. They can predict. The prediction will be done based on the previous data. They would have trained some set of data. So stock market operations can also be predicted by using AI, sir. I'm not well familiar with stock market, but I can tell that we can. So how strong AI will be different from weak AI? So what is weak AI and what is strong? We have to differentiate. The strong AI will be coming under our robotics and all, where it can understand and do by itself. Weak AI is like our what we can tell. The best example of weak AI. This can be helpful to detect more than one disease. If it is related diseases, we can detect, because the data set won't be giving the entire information about the patient, but we can detect.
Thank you, ma'am. So now I request our principal, sir, to address the session. Over to you, sir.
So good afternoon, everyone. So Department of Computer Application, Dr. NSAM FGC, the institution under the banner of NITE Education Trust. So a 5-day National Faculty Development Program, the second day guest, Madam Uma Maheshwari, Madam. So like I was not there when you started the session, I was having one more session. And all the participants of today's program and yesterday's program, another 3 days to go. It's a wonderful session. Yesterday also I was there in that yesterday's session and it was fantastic. And today also, exactly 2:45 I joined to this session. And it was really whatever the which you have discussed. So I hope another 3 days to go. So very good resource people we have from the institution. We are providing a fantastic FDP program and request all the participants to participate another 3 days this faculty development program and utilize and gain the knowledge. I hope Department of Computer Application is doing justice in providing all the information through resource people. Okay, once again, I wholeheartedly thank Uma Maheshwari Madam for addressing and clearing the doubts related to the topic which you have discussed today. So once again, all the best for another 3 days, Department of BCA. So whatever the questions are there, so make sure that chat box or whatever the technology related things are there. So it will be reaching to the resource person and later on in future also. So if they have any questions, please share resource people email ID so that they can ask directly to them. So once again, I congratulate and successful completion of second day faculty development program, Department of BCA, all the faculties Once again, I congratulate. I thank each and every participant who participated and utilizing the opportunity given by department. So thank you very much. Over to you, Department of BC.
Thank you, sir. Thank you so much, sir. And special thanks to you, ma'am, from our
Thank you so much, sir, for giving the
Department of Computer
opportunity.
Applications. And
Thank
it
you,
was
sir.
very informative session, ma'am. And
Thank you, sir.
dear participants, the feedback form will be shared in the WhatsApp group. Kindly fill up the feedback form. And thank you, everyone. Thank you, ma'am.
Sir.
Thank you.
Thank you, sir. Thank you.